Hello, everyone. My name is Jelle Beekma, and on behalf of the ASEAN Smart Cities Trust Fund team, I would like everyone to thank everyone joining us for today for a fascinating discussion on how digital solutions are being used to enhance resilience and improve asset management of water utilities via real-time dynamic monitoring and control systems. This webinar is organized with the Australian Government Department of the Foreign Affairs and Trade and the ADB's Water Sector Group. We have a great speaker lineup this afternoon, so we do want to get started soon. Next slide, please. This is the fourth session of our ongoing ASEAN Australia Smart Water Seminar. With each session focusing on a specific digital solution that aims to help the cities to tackle specific issues related to the improvement of city planning systems, service delivery, and financial management. If you wish to receive invitations and updates about the upcoming sessions, then please do sign up to our mailing list and use the QR code or the link on the upper right side of your screen. Next slide. Before we proceed with today's discussion, just some quick housekeeping announcements that we want to share with everyone. First of all, the slide presentations from this session will be shared with everyone a day after the webinar, along with a link to the webinar recording, which will be uploaded to our YouTube channel. We will also be sending a link to our post-event survey, and we hope that everyone will take the time to fill it out. Your feedback will be greatly appreciated and help us to understand what you want and how to improve our future webinars. Next, please. After our panel discussion, we will open the floor for questions and discussions. In the interest of time, we will not use what you usually have the raise hand function on the Zoom platform, but we will encourage everyone to submit questions through our special question and answer box as we go along the webinar, and you will find that on the bottom of your screen. When submitting your questions, please do indicate which speaker you are directing to for questions, and we will try to accommodate as many questions as the time will allow us. Next one, please. To kick off today's webinar, it's my pleasure to introduce Ms. Andrea Faulkner, the Australian Ambassador to the Republic of the Union of Myanmar, and I would like to invite her to give her brief introductory remarks. Ambassador Faulkner is a senior career officer with the Department of Foreign Affairs and Trade, and was recently the Assistant Secretary of the Sustainability and Climate Branch. She has previously served overseas as a head of mission of the Australian Embassy in Tel Aviv, as a deputy head of mission in Hanoi, and as first secretary in Paris. Without further ado, over to you, Ambassador Faulkner.
Thank you very, very much. Good morning and good afternoon. Mingala Ba. I'm just checking that I am on screen. Yep, great. All right, thank you very much. Please let me acknowledge you, Jelle Beekma of the ADB, for moderating this webinar. Acknowledge all of the fellow panelists and everyone who's participating. And thank you for inviting me to provide opening remarks at this ASEAN Australia Smart Cities webinar. It's the fourth in the series, and it has a very clever and intriguing title of Intelligent Water Management Systems Using the Internet of Things and Artificial Intelligence. The challenge of providing clean drinking water to the growing cities of Southeast Asia is significant, and we are proud that Australia is playing a part in addressing this challenge. Smart water is a term for the opportunities that information technology presents to water service providers to deliver more efficient water management and to better serve the people who use the water, which is everyone. Smart water has enormous potential. Using information technology, we can strengthen water security, improve service delivery, and build resilience against the impacts of climate change. We can grow supply, reduce operating costs, and increase water quality. Now is the time to seize those opportunities. So today I'm looking forward to hearing about current and proposed projects such as the pilot Yangon City Water Resilience Project. This will assist Myanmar to develop smart water management solutions, and for everyone who's living in Yangon, that's a really high priority. We all want our cities to provide us with a good quality of life with a sustainable environment. That's why Australia, as a long-standing partner of ASEAN, is so pleased to support this project through the ASEAN Australia Smart Cities Trust Fund. The Smart Cities Trust Fund helps ASEAN cities to become communities that are greener, more competitive, and more resilient for everyone who lives in them. Specifically, it draws on Australia's expertise in green infrastructure, water governance, renewable energy, innovative technologies, and data analytics, and combines with ADB's experience in supporting development work in our great region of the world. Thank you for the opportunity to open this webinar. I hope everyone enjoys it and finds it informative and practical and of real assistance in your important work. Jesu Dimbade, thank you very much. Thanks very much, Yella.
Thank you very much, Ambassador Faulkner. That was a very brief and quick overview and very nice pointed to. I saw two things: the green infrastructure, which I think is a very important point to think of as well, and how we combine that actually with what we do today, this artificial intelligence and Internet of Things. Before I introduce our first speaker, we are launching an audience poll to see what you as the audience feel. And we have our first question here. How well do you think your local water utility is using digital technology in water management? 5 choices. Extremely well, very well, fairly well, and not well at all, or not applicable. And please do select your answers now, as we will be closing the poll quite soon. Is everybody made their choice? Then we close in 5, 4, 3, 2, 1. And we see that fairly well is somewhere in the middle. So let's see what today's webinar can help us in stimulating this a bit further and going further on the way. Thank you very much. And we will start off the seminar with Dr. Fang Chen from the University of Technology of Sydney. Dr. Chen is a thought leader in artificial intelligence, data science, and is going to give us a very, very fascinating presentation on how these are being used in the different systems. She's been working in Intel, Motorola, NICTA, CSIRO, and UTS, and has helped government and industries utilizing data and significantly increasing productivity. And you're going to see a few beautiful examples of that. Today we will discuss data-driven water solutions, and without further ado, over to you, Dr. Chen.
Thanks, Yella. With the huge amount of the data available, data-driven decision-making becomes a natural trend in business and operations. AI is a powerful tool utilizing data and insights from data and suggest intelligent actions. As our ambassador said, now it is the time. Next slide, please. So from this picture, you can see clearly there are two options. One is we call reactive maintenance. On the, our infrastructure is getting older, particularly we're talking about in water pipes buried underneath of the, the ground for hundreds of years. And then old-fashioned typical reactive maintenance is use periodical scheduled or gut feel approaches using some business process of course, combined with the domain expertise, some gray-haired experience, which is all good. But a lot of the manual inspections, manual decision-making involved, which is costly and time, and not timely. To avoid the failures like you see on the picture, which is not a joke, is a real incident that happened a number of years ago. The water pipe failure created 13 floors of fountain. I'm sure there's, I mean, people, you want to like it, we don't want to see it. And in order to avoid those kind of a catastrophic failure, one of the ways to go ahead is utilizing more preventive maintenance based on real data, failure history, sensor data, industry-specific attributes and constraints to predict where is the high-risk pipes and then to stop that in advance. Next slide, please. I'm going to use a project to illustrate how we actually can do it. You look at this one, this is an actual plot of incident over a certain area, which is inside Australia. You can see all those dots, every single dot are the failures happened in past 20 years. And of course, the different color of lines that shows different pipes. Green color shows the critical water main, which is large size, or it is under critical infrastructure. If you look at the background color, actually soil, of course, the different soil type. You know, you have acidity, you have a different reactiveness, etc. So this is only showing the complexity of the problem. If you have so many failures happening in the past, if you try to understand which pipe is have a high probability to fail, what are you going to do with that? If you are one of the maintenance manager, which pipe you're going to pick to stop the potential risk as we showed in the previous picture. So next one, please. Of course, sensing and AI are one of the choices and has demonstrated significant success in the past and will lead to a lot of success in the future as well. So on this one, you can see the sequence of what are we going to do with the sensing and AI. So when you have various different sensors buried along the pipes, and we can get a lot of the signals around, and we can do, you know, first thing, the AI data science or data analytics will help to decide where to deploy those sensors, and also we can generate some of the desktop-based risk map to guide those sensor deployment. When we actually deploy the sensors into the ground, then various different signals coming. Using those signals, of course, we need to clean and do some, you know, intelligence check first. And then these signals will provide insights into what kind of leak and break signals will sound like, for example, and then we will use those information to confirm with analytics on the potential risk of the failure risk, and that will lead to the early alarms and early inspections into the potential, you know, the pipes with a high intensity of breaking. Next one, please. So this is, you can look at the actual risk map look like. So if you look at the left corner one, is the top 1% of the high risk pipes. And you can see listed in red color. And the middle one is pink color, is the top 2% of the risky pipes. And the right-hand side is the top 3%. So this gives you a clear indication of which pipe, which section you may need to pay more attention to. So next one, please. With one piece of this technology, which is the failure prediction, that a high accuracy scheme, thankful to the AI and IoT, brought a game change to the equation. So based on the estimation coming out of the Deloitte's Access Economics, it shows that the savings to Australian economy, just based on the critical water demand, that will exceeding 300 million. Next, please. Not only smartness in failure predictions, this one shows how we can manage the water network, drinking water network smartly using, of course, sensing and analytics. To run an intelligent network, a few key elements. One is deliver quality water. Of course, we always want to improve. And then also we need to maintain the current, maintain the continuous supply and reduce energy. So you can see the picture shows the awareness of the water quality, and you use demand different profile, and we can manage intelligent network in the best way. Next one, please. So this one I want to talk details, but basically it's based on the sensors and the AI. We produced a sewer chemical dosing operation toolkit. So yeah, you can see there's a real-time feedback on how much dosage you should have on the chemicals, and what's the impact towards your H2S levels in the pipe, sewer pipe, for example. The next one, please. So to conclude is a lot of intelligent approaches we can utilize in, from AI and IoT perspective. And we worked with more than 30 global utilities and have proven all those ones brings in significant improvement in terms of productivity, efficiency, and cost saving, etc. And I want to read through the list of the industry recognition, but I'm trying to emphasize on this is the time, and would love to work with the community and to deliver more AI-based solution to make our water management smarter. Thank you. Thank you.
Thank you. Thank you very much, Dr. Chen. This was impressive. Thank you. And I was especially impressed by the reduction of the cost, and then also even reduction of the chemicals that you can bring together, and your wish to go to community level. So I'm sure that there will be many questions about it. Before we go to our second speaker, we would like to have a second audience question. And you can read it all on the screen. How satisfied are you with the service that you are receiving from your local water utility? And here we go again from extremely satisfied, very fairly unsatisfied, and extremely unsatisfied. So everybody please select your answer. We did this quite quickly last time as well, and we want to hear more from our speakers. So we will be closing the poll soon in 5, 4, 3, 2, and 1. And let's see, we're again somewhere converging in the middle. 59% is in the middle, so fairly satisfied. Let's see what we hear more today, and how we can convey that message and see how that's gonna improve our water services. We're moving now to our second speaker for today, Mr. Robin Schlenga, who is a senior data analyst at Rambo Management Consulting. Robin is leading the organization's German data science digital innovation team and is responsible for a major innovation project in the analysis of wastewater samples using machine learning. This afternoon, he will be discussing on smarter water, and without any further ado, over to you, Robin.
Thank you, Jelle, and a very good morning from Germany. It's 6:20 here in the morning, so forgive me if I sound a bit tired. Thank you for having me. So as Jelle said, I'm from Rumble, and Rumble is a company, a global engineering company that drives to deliver sustainable solutions. And I myself and my team is working in the AI and data sector of that. So on the next slide, I'm going to present to you a couple of actual solutions, a couple of actual projects that we've delivered using AI in the water sector. The first one is for water suppliers, where we help them to predict the consumption of drinking water for their city. Next slide, please. So the AI solution that we created uses and leverages several kinds of data streams. First of all, it uses public data. That can be calendar events, like if you have a big concert in your town. It could also be the population numbers, the mix between population and industry in the city. Another data source that is very important for drinking water is, of course, weather data and climate data. So what is the temperature going to be tomorrow? What is the rainfall going to be? And then we combine those two data streams with the previous day's consumption of the water supplier that we're working with. So the last couple of days, how much water has been put into the system and how much water has actually been used. We combine all of these data, and on the next slide, we feed them into a machine learning model. Machine learning, that's just the technical name for artificial intelligence. So that's a neural network, and it trains by looking at several sets, many sets of data, and tries to learn what brings those data together. So it looks at the historic consumption data of our clients, and it learns how all of these data streams come together to actually generate a very good prediction for, on the next slide, the actual drinking water. So this prediction that we do here, I presented as a daily. It could be in different frequencies, weekly or per second, just depending on what kind of data the clients have. So on the next slide, I will try to show you how good this is. So the prediction that we generate, you will see now matched against the consumption. That is what you see here. So this is the consumption of one particular client that we had over 1 year. And you see lots of spikes, and it goes up in the summertime in Europe, and it goes down in wintertime with some spikes around Christmas, of course. So what water suppliers usually do is they have experts, and on the next slide, you will see what these experts predict the drinking water will be. So if you go forward one step, please. Thank you. So now in red, that's what the expert puts into the system. That's how much water our client put into the system. And you see this is a very good approximation of the actual consumption, but you see, especially in the beginning of a year, that there are many spikes around the actual consumption. And that's bad, because that means you're spending a lot of energy to pump more water into the system, or sometimes you have too little water in the system. And if you go one step ahead, please, you see our prediction, which is a bit closer to the actual consumption curve. So it helps you to reduce the energy cost for pumps. But I want to be very clear, we would never use something like this or tell anyone to use this as a completely automated tool, because there will always be times when the human expert just knows better. So we use this as an expert assistance system. And you see it in this June, July time, there's a very high spike in the actual consumption that our tool did not predict. And that was just something where the human expert knew what was going on. So we always believe in bringing together artificial intelligence, human intelligence. And this, if you go one step forward, this tool is over the 94% accurate over the time and over all our several clients for this. In the next slide, you see how this actually looks like. So we offer our clients a dashboard where they see the historic consumption of the last couple of days and the prediction for the next day in that case. Again, it could be something else. And the trend forecast for the next 5 days if general consumption levels will go up or down. To implement something like this, we of course need access to the data of the clients. And then we can set it up as a protected web service or something that is implemented on premises, depending on the needs. On the next slide, I briefly touch on two different project samples that focus more on wastewater, and it's about chemical and microbiological analysis of the wastewater. So on the next slide, you see a system that's very similar to what you just saw. It's just for chemicals in wastewater. So again, we're using several kinds of data to train a machine learning model, which then acts as an early warning system for the thresholds of chemical concentration in the wastewater. Since this is a very complex task, we cannot just use historic data, but we have to also include the domain knowledge of how the actual plant is working, how the pipes are connected, and things like this. So we first collect these information and build a digital model of the plant that then is used as the basis for our machine learning model. And on the next slide, you will see our approach for microbiology, which is about detecting bacteria in wastewater samples. So usually the process is that a wastewater sample is taken and then shipped to a laboratory somewhere. And on the way, the bacteria might die or they might just get lost. Then in the lab, an expert will look at it and generate a report telling the wastewater treatment plant what the correct state of action should be, the course of action should be to possibly remediate the situation there. With our tool that's called OpsEyes, now the process is much, much quicker. You can just upload images of the wastewater samples that you take with your smartphone through the microscope. So there are several attachments that you get for free, and then you put the smartphone on the microscope, take some images, and the AI does the rest. So this is less than 30 minutes in total, which, if you want to do the math, it's 240 times faster. And then on the next slide, I just quickly like to give you some passing remarks. Of course, there are many different technical aspects that have to be taken care of in a project like this, but much more important in our experience than the technical aspects are the cultural aspects. And I'd just like to give you those four strong, bold headlines to make things like this possible. So acquire new data sources, always be on the lookout for interesting new data sources that might help you. Experiment with new methods of working together, bringing value out of these data sources. Encourage unconventional solutions in your organization, bringing people together and allowing exchange within the organization. That is, in our experience, a very strong predictor on how AI solutions will actually come to work. So thank you very much.
Thank you very much, Robin. That was really interesting. I liked actually to see how you compare also to the peaks that are not prepared by or predicted by the machine, but by the humans. And of course, it's quite impressive to see that you go 240 times as fast with the microbiology. We'll surely discuss this much further later on. So before we proceed to our third speaker, we would like to do a quick third audience question in this afternoon, for this afternoon. And an easy one, 3 answers only. Do you think that the digital technology can help improve water quality? And what and the service that your water utility provides? And there's a yes, no, and I'm unsure. So since there are only 3 answers, let's give you even a bit shorter so we keep more time for our interesting discussion later on. So everybody, please select your answers. And we will be closing the poll in 5, 4, 3, 2, 1, and get our results. Wow. Well, that's a clear one. 96%. Well, let's see. We're all very much in favor of what we're listening to today. That's very good. We draw lessons learned. And so it's very nice that we go to our third speaker, Mr. Mo Ting Lang, the Deputy Director of the Industry and Technology Collaboration Department of the PUB in Singapore. National Water Agency, who will give us some real practical experience on this. Mr. Ting Liang currently oversees the PUB's technology collaboration efforts with the aim to grow technologies through partnerships with industry and other stakeholders. And he leads a team to commercialize water technologies that are co-developed by the PUB. This afternoon, he will discuss the Singapore experience with smart water. So please, over to you, Mr. Ting Liang.
Hi, can you hear me? Hi.
Hello.
Can you hear me?
Yes, we can hear you well.
Okay, hang on. Let me just... can the organizer put up the slides, please?
They should be on the screen now. I see them.
I see it. Okay, good afternoon, everyone. My name is Ting Liang Mo from PUB, Singapore's National Water Agency. I thank the two speakers before me, Professor Chen and Robin, for giving a brief introduction about data analytics and artificial intelligence as applied to the water systems. And it's a good introduction because I'm going to touch on this as I share with you how PUB as a water utility applies such technologies in our service delivery. Next slide, please. So for those who do not know PUB, we are the National Water Agency of Singapore. Our mission is to supply good water, reclaim used water, as well as tame storm water. What you see on screen is what we call the water loop. The outermost loop is the conventional water cycle where you collect rainwater and turn it into drinkable water. And what you see in the middle are the two newer sources of water. One is the reclamation of used water into drinking water. And right smack in the middle of the screen is desalination. So effectively, we have applied digital technologies in all aspects of our water supply and water reclamation operations. Next slide. So the drivers for us to pursue digitalization of our water system are as shown. There is increasing water demand from the population. In fact, we are supplying about 2 million cubic meters of water a day. We expect this to double in another 40 to 50 years. Costs are rising, and as you can see from my previous slide, because we use water recycling and we use desalination, there is a higher energy component to each unit of water produced, so we need to manage that. We also face the challenge of an aging workforce, just like any other developed country, and we have to meet higher public expectations. Just now, interestingly, for the second poll, I noticed that only 59%, sorry, I should say 59% of the people listening in today says that they are fairly satisfied. And I would expect a higher percentage to be either extremely satisfied or well satisfied with what the utility is providing. So there are various risks of not innovating, as shown on the slide at the lower half of the slide. And that includes cyber threats, technological obsolescence, as well as lack of long-range solutions to meet future challenges. Next slide. So over at PUB, we do focus on 5 technology enablers, and we plan to deploy solutions in each of these 5 areas over the next 5 years. And this includes Internet of Things, data analytics, digital twin, artificial intelligence, as well as greater use of autonomous system. So as I mentioned, the two speakers before me have elaborated on data analytics and the use of AI. The Internet of Things is important so that we can connect sensors and devices together. And the use of robots is becoming more pervasive. I think there has been a lot of talk about using drones for surveillance, and I'll be sharing some examples later. So the end goal of deploying all this in PUB is to better deliver our mission to our consumers We want to achieve operational excellence with a leaner workforce, and we want to enhance our system oversight and situational awareness. Next slide. So this is a busy slide, but let me simplify it for you. Essentially, what we are saying is that we are going to deploy IT or digital solutions across the entire water loop, starting from the water collection, the rainwater collection system upstream, to the plants where we treat raw water into drinking water, to the water supply network, and then to the sewage network, which will ultimately be where we collect our wastewater and turn it back into drinking water again through our water recycling system. And of course, this is undergirded by digitalization of the entire workplace, as well as provision of operational support systems to help our people achieve their mission more efficiently. I'm going to go into some examples next. So over at the smart plants, there are two areas that we're looking at. One is operational efficiency, and the other area is safety and security. So for the operational efficiency part of the house, we are using more sensors, more robots to capture data. And this data by itself is not useful, so we need the analytics portion to turn that data into useful information. That means sense making of that data so that we can enable prescriptive and predictive decision support. I mentioned about the use of robots, and this can be used for sample collection, it can be used for surveillance, and nowadays we're talking about wireless sensing as well. So that's on the operational efficiency side of the house. On the safety and security side of the house, we are using drones and robots for surveillance. We are trying to encourage smart wearables for our staff, so that if they get into trouble, we know that they are in trouble, and there's more pervasive use of CCTVs for video analytics. Next slide. On the network side of our operations, we have sensors in our water supply grid. Currently, we have over 300 water sensors deployed for our portable water system, and we also have an additional 100 sensors for the new water, industrial water networks. For the drainage side of the house, we have installed flow sensors and water level sensors. This will enable us to give preemptive warning to the population in case the water levels in the drains are rising rapidly and there's a chance that there could be an overflow leading to a flood incident. And last but not least, on the sewage side of the house, we also install sensors in our sewers to monitor flow, to monitor VOCs. I'm going to go into some more detailed examples next. So I have three examples here. One example is a toxicity measuring device that we put in our sewer system, and this enables us to detect illegal discharges of heavy metals into the network. And because we use the wastewater for water recycling, it's very important that we ensure that our used water is of the correct quality so that it can be recycled. Next. The second example is the use of drones with a hyperspectral imaging camera carried beneath the drone to monitor algae blooms in our reservoirs. This will enable us to better monitor our water quality in terms of parameters like chlorophyll A or turbidity, and it enables us to map the water quality without limitation, such as satellite imaging, which is prone to crowd cover disruptions. Next. And this is my last example. We talk about the use of UAVs to check our deep tunnels. We have a system of a deep sewage tunnel, which is about 48 kilometers long and between 3 and 6 meters in diameter. There's no way a human can go down into the tunnel to check the integrity of the tunnel, and so we send a drone down with a camera to help us check on the integrity of the tunnel. And this is a project that is under development. We hope to deploy this technology soon. Next. And to promote the use of technologies or digital solutions, we have the Singapore Water Exchange, which is a purpose-built infrastructure in PUB to encourage water companies to come together and collaborate to develop such solutions. So this water exchange currently houses about 27 companies. Some of them are in sensors, some of them are in water treatment, wastewater treatment. We bring them together so that they can collaborate more easily together with PUB to come up with new solutions to tackle the challenges that we all face. Next slide. And last but not least, I just wanted to share a bit about the Singapore International Water Week, which is happening next year in June. But before that, and then later this month on the 18th and 19th of November, we do have an online version of the Singapore International Water Week, where we bring together panelists and experts to talk about different aspects of technology being used in the different water treatment systems. We would like to encourage each and every one of you to come on board to listen to the experts. Please register at the Singapore International Water Week website, which you can easily Google. So I welcome all of you to join the event later this month. And thank you very much.
Thank you very much, Mo Tin Liang. This was a very interesting presentation. And I think what was really nice is that we see that it's not only theoretical and models, but that you're using it completely in your operations. I was very impressed by that. Thank you so much for this interesting journey through your system. Also the explanation of the system from robots till remote sensing, amazing. Before we open the floor to questions and answers, we have our last audience question this afternoon. This is a little bit different from our first three questions. We will be using a web-based tool. It's called a Mentimeter. You can access it by going to www.menti.com, using your desktop or mobile browser and entering the codes 5147948. You can also scan the QR code that you see on your screen with your mobile, or refer to the Zoom chat box where we have posted the link, the URL that you can click. I think the next slide. Let me see that. Yeah. This time we'd like to get your views on what other topics you'd be interested to hear about in our future webinars. It's an open-ended question and you could submit 3 possible suggestions. We will keep it open until the end of the webinar, and we will then check back with you on your responses. So we have a good idea of what is interesting in the future for you. Let's open the floor for questions. I see that we already have a few in our question and answer box. And for those who would like to still submit a question, please click on the question and answer box on the bottom of your screen, or if you use an iPhone, on the top of your screen. Indicate which speaker you're directing your questions to, please. And we will try to accommodate as many questions as possible. So let's go to our first question from Mr. Frank Wafula. How much would a smart water management system cost, and to which of our presenters is this going to be asked? Could I please get that, Mr. Frank? We would like to answer this question live, so who can we go to? I think the most logical one would probably be to the PUB.
Yeah, I was thinking that you may direct the question to me. So thank you, Frank and Yele, for the question. I think it's hard to pin down a precise cost to how much such an implementation would require. Definitely it will be in the hundreds of millions of dollars. Currently, we are embarking on a project to install about 300,000 automatic water sensors in Singapore, covering both domestic and non-domestic users. And this project will take us probably 2 to 3 years. And this project would cost us about a few $100 million already. So this is just one project alone. But I think what is important to highlight here is that nobody is asking any water utility to implement the whole suite of solutions in a short span of time. But we need to start somewhere, and it's a gradual process to bring us from where we are today to the desired outcome of being a fully digital utility. And to enable this, of course, there'll be investments required. It's not going to be cheap, but I think as technology matures, the cost will come down. But I think, and this leads me to my final point, which is to say that for utilities to be able to afford such an investment, there must be correct water pricing, water tariff, so that the utility is able to accumulate some surplus to invest in such technologies. I think that is key. Thank you.
Sorry. Thank you very much. Yeah, that was an excellent answer. I think quite complete and also very practical to the different type of utilities we have. And then I have a question specifically for the Philippines. I see. Are the Philippines water providers in the map of technology sharing with other countries? To whom do we want to ask this question? Maybe more to somebody from the organization. Who would like to take the floor for answering this one? Would we? Okay. Anybody from our panelists?
And this is the question, Yala, this is the question that is asked regarding the Philippines water provider.
Yes, correct, yes. But I think that's not really you, Mo, who should probably answer that. I was wondering who could answer that of our group. Let's maybe go to the next. So this is about water infrastructure, which are mostly managed by the government. It is probably much easier to apply these type of technologies in developed countries, as we had also the example, of course, from Singapore. To all the speakers, so maybe we can go quickly around. Did you have any experience of applying these technologies on developing countries where the government is more challenging to work with? And let's start with you, Dr. Mo, and then maybe go to Dr. Chen and to Robin as well.
Hang on, I'm just trying to read the question again.
Okay. So it's basically the difference between, let's say, having the developed countries sort of technology and financial resources, I suppose, and what is the experience in more challenging conditions?
Okay, so
if we have any.
Okay, so for PUB, we do not have any experience of working with the developing countries for such smart technologies, but we have received many visitors from the developing countries to look at what is being done here. We share our experience. We understand that every country is unique. Every solution has to be adapted to the country that we're talking about. So yes, I can understand that it could be a bit challenging to deploy some of these technologies in some countries. But I think what is important is that there must be a vision and leadership will to move in a certain direction. The technologies are there. It's a matter of having that will to get it done, that policy directly to get it done. And over years, I mean, in the span of a few years, I'm sure that it can be deployed, it can be the vision can be achieved if everyone put their hearts to it.
Thank you very much, Mo. Let's maybe ask Dr. Chen.
Thanks, Yela. I have worked with a few funding agencies on several proposals around, in developing country. I think this is definitely a challenge. However, the challenge is probably is not only in water or in technology, it's probably in all aspects from how government is running and what are the important agenda, the things on the agenda for particular government. I think there is, the challenge is over everywhere, not only in developing countries. In developed countries, the same. Is what are the top agenda from government or from the agencies who's managing water? The second one is sometimes is the social benefit. That part may be overpass or overcome the money side. So how important the social benefit part is, provide a clear drinking water, for example, for health issue, all those ones, it's very important to count. And I would say it's no way, I mean, not absolutely say easy one way or the other, but eventually is probably improvement and ROI that will play an important role into the whole deployment or development, and of course backing by the operating agencies and the government. That will be always important aspect needed to consider.
Thank you very much, Dr. Chen. I think those are good points. I know that from the ASEAN Development Bank, we're working, for example, with Dhaka Water Supply, and they have implemented quite a few of those solutions and are busy with integrating this more and more. Let's go to a next question, I think. We have a specific one, again, on the costs and the of the infrastructure, particularly again in Singapore, and there's another one specifically to Ms. Chung again. What basic data were used and required to identify the pipes for replacement? We saw one interesting slide of that. Were extensive sensors required for this exercise? Ms. Chung, could you please come in on that one?
Sure. So the data comes from few categories. The first one is pipe attribute itself. Say for pipe length, material, wall thickness, and diameter, etc. That's the basic one. The second one is environment, basically the soil condition, weather, for example, and then even depth, how much, I mean, how deep it's buried in sand or in whatever. It's never have a complete set, but at least if you have those information, that would be helpful. The third category is operational. For example, pressure. For example, that the loading, loading means that when you have water pipes, you have the road traffic on top of the water pipes, and how heavy trucks will going through those ones. And the last category is you have to have some past history of the failures, so that you can understand all those attributes, how they related to the failures happening in the past, so that you can draw some of the pattern or learn some of the patterns. Okay, I'll stop.
Thank you very much, Dr. Chen. I'm sure you can go on for a long time on this one. We have a question for Robin on the neural. If you only use neural networks for prediction of water consumption, or if there are any other issues. This is a question from Mr. Bambang, or from Bambang Rizal.
Yeah.
Please, Robin, if you're there, could you come in?
Yes.
Yeah.
Yes. Thank you for the question. It's a very good question, and it depends on a couple of factors. So the most important factor is how much data do we actually have for the clients, so from the client. So different architectures require a different amount of data to actually be feasible. So if you have a client who just wants to get started and try something out and has just a small set of data, we would use probably no neural networks, but tree-based models. The famous XGBoost is the standard for some stuff like this. Several approaches in that direction. And then it scales up to more complex neural network architectures that can be used if the database is good enough. So in the best case, we use combinations of so-called LSTMs, which are, that's called long short-term memory networks, which are very deep neural networks that have a structure that is specifically made to understand and predict time series. So they understand the temporal aspect of those very well. That's what we use if the databases allows for it.
Thank you very much, Robin. Very clear for those who speak the technology language sufficiently, I think. But it's another question from Kyo2 is how important it is to have safety and safety net and backup systems for the data to critical infrastructure as well, and if there's any system crash or virus attacks or disasters, how do you deal with that, and how do you deal with these systems then? And I think it's good that we ask everybody. Maybe we start with you, Robin. You're already on screen, and then we go to Dr. Chun and Mo. Thank you.
Sure. Well, yeah, this is of course very important. It's mandatory to have very good IT security and stuff like this. I would just like to highlight an aspect of this. So it is just out of discussion to compromise on IT security on something as critical as water infrastructure. However, it is important that the IT department of the organization that runs all this understands that there's a need for innovation and provides tools and access to the data if it is in any way possible. So this is something that sometimes has to be found a balance between.
Okay, thanks. Over to you, Dr. Chun.
I guess my answer is very quick and short. Yes. So very important.
Well,
Can't stress more. I may save a bit of time for POB to comment on.
Yeah. I think it's extremely important to take care of cyber security to prevent hacking incidents into the systems that deal with water. And this is where, like what Robin mentioned, you need the buy-in of the IT department and have the whole organization believe that there is a requirement to digitalize, but at the same time, we need to put in the necessary defenses to ensure that this system is not compromised. In any case, we shouldn't let the fear of cyber security hold the utilities back from digitalizing. I think that's the key point I wanted to make.
Thank you very much. I think there's time for just one last question. Please, let's stay with Dr. Mo. The idea is like, there's a question from Mr. Frank again, Wafulo. Working in a city with many different providers and different systems, how can we benefit from these the sensors and stations in place? So how do we do this in
Okay, I know that we are in a COVID situation, but I'm not sure where Frank is from, which country you're residing in now, but I would like to extend an invitation to you to visit us once we get COVID under control, and we can share with you what we are doing here, and you can see it for yourself. But before then, I am not sure when this will be. I can probably send some information to you about the sensors, about the solutions we have put in our water water supply and sewage systems. I can also share with you about the solutions that we have implemented on drones for surveillance. So if you may, perhaps you can contact me separately through the ADB. They have my contact email, and I can have a further conversation with you.
Thank you very much. I think we have to close. We're already over time. I think we would love to continue for hours, but unfortunately, people have other things to go to. So thank you very much, everybody. Thanks so much for everybody that gave also their answers for the last poll questions. And we will address those in the future webinars. And speaking of the future webinars, we have one on December the 8th. It will be discussing digitized solutions for future webinars. Digitized solution connecting labor market and students. And if you would like to get invitation and updates about our upcoming sessions, please do sign up to our mailing list or through the QR code or through the upper right side of your screen. As mentioned earlier, all participants will receive an email with the link to the post-webinar evaluation form, a copy of the presentations, and also the suggested new topics. Please follow us on the social media as well. And on behalf of our speakers and our organizing team, thank you so much for joining us. Thank you very much for all the speakers, for the very interesting discussions we had and the presentations. And we hope to see you on the 8th of December again for our next webinar. Thank you.
Thank you, Ella. Bye.
Bye-bye.
Thank you. Goodbye.
Thank you. Bye-bye.